Welcome back to Discovering Geometry with Mrs. Berry. This is lesson 41. Today we will be looking at practical examples with circumference and pi within our circles chapter. The first problem is around the world. If the diameter of the Earth is 8,000 miles, find the average speed in miles per hour that Phileas Fogg needs to circumnavigate the Earth about the equator in 80 days. Remember this book, he was challenged to circle the world in 80 days. How fast would he have to go to do that? So first, we need to know the distance around the equator. We are given the diameter, and the distance around the equator would be circumference. What was our formula for circumference? It was d times pi. So I'm going to put into my calculator, I'm going to use the pi button. And when I multiply that by 8,000, I get 25,132.7. I'm going to carry this 0.7 around just until I get to the end, and then I'll round it to the nearest 1. The next thing we need to do is to calculate a rate. So to calculate speed, it comes from a rate, and rate is distance divided by time. Think about in your car when you're driving, you drive in miles per hour. That would look like this: miles, the number of miles, over the number of hours. So it's distance divided by time. Well, we have distance right here of how far it is around the equator. Now I need to know time. We have it in 80 days. I don't know that we want to calculate exactly how many miles a day. I think we want to know miles per hour. So we're wanting to do miles per hour. To do that, I need to change my 80 days into hours. So how many hours are there in each day? 24 hours in one day. So our days will end up canceling out. We'll have 1 in the numerator and 1 in the denominator, and we'll be left with hours. 80 times 24 is 1,920 hours. Now we can divide the total miles by the number of hours and see what that mile per hour rate is. I get that it's 13.08. That would be miles per hour. And then I would go ahead and round it maybe to the nearest units place, so 13 miles per hour. It doesn't seem very fast to do that in 80 days. Let's look at another example. The park ranger at the Redwood National Park is often asked, what is the diameter of the giant redwood tree near the park entrance? She decides to help one group of students find out. Knowing that a person's arm span is roughly the same as their height, she asks the students to hug the base of the tree with their arms outstretched, just touching fingertips. So if their arms are outstretched, that's going to be their arm span. If they just barely touch fingertips, that would be their arm span, and that would be equivalent to their height. So if the students who were able to ring the tree had heights of 138 centimeters, 136 centimeters, 128, and 126, what's the approximate diameter of the redwood? Now I want to say that I pulled this problem from your book, and it does not seem very accurate to an actual redwood. But we can use what we were given to figure out the diameter of whatever tree they are hugging. So if I add all of the heights, what is that going to give me? Is that the diameter of the tree or the circumference? Well, they're going around the tree. So here's our tree. They're going around it. So that's going to be the circumference. The total circumference is all of their heights, or their arm spans, added together. So 138 plus 136 plus 128 plus 126 is going to give us 528 centimeters. So from there, how do we get the diameter? Our circumference is pi times our diameter. We know that our circumference is 528. So how do we get d by itself? We divide by pi. So if I use the pi button on my calculator, 528 divided by pi gives me 168 centimeters. If you would like, you could put that into meters, and you could say that it's 1.68, or maybe you even want to round to the nearest tenth and call it 1.7 meters. And I'm just not sure that that's as big as the redwood tree would really be. But that was the numbers that we were given. So maybe look up the diameter of a redwood tree and see if you think if this problem is accurate or not. There's just a few more problems like this in this section of the book. So use your formula for circumference, either pi d or 2 pi r, to figure out all of those problems.